Okay, in this example, we have this V-shaped wire. Um, each segment is a length of 1 meter separated by an angle of 60 degrees. And so each piece here is 30 degrees with respect to the vertical. The wire carries a current of 2 amps, and there's a magnetic field of 2 millitesla directed as shown, so it's up, and the magnitude and direction of the net force acting on this wire are. So I'm looking for the net force, and I'm looking for magnitude and direction. So one of the things, just looking at the answers, my force is going to be either into or out of the page. Um, remember that the force, when I have current, my force is equal to I L cross B, right? So my eye is pointing this way on the left, and it's pointing up on the right. And so the way I like to think about it is I could do the math. So I could say, there's two ways I can do it. I could say there's the math, so that's going to be I, L, B sine theta. We can do the math way. And then what's the angle? The ILB sine theta. So this is my I, and so then I need to think about my B field points up, and so I'm going to need to calculate that sine. So this is the sine of the angle between them. So let's see if I can erase. Oh, I can erase theta. So I'm going to have to go around. So 180 minus 30 would be 150 degrees. So my theta is going to be 150 degrees. But I can also think about just the direction of the force. So one of the things I like to do is whenever I have a vector that's not in the perpendicular to B or parallel to B, right? Perpendicular to B, phi is perpendicular to B, I just get ILB, because when it's perpendicular, that's 90 degrees is different, and so sine of 90 is 1. When they're in the same direction, the angle is 0. So either the same direction, if it's parallel, same direction, or opposite, it's either 0 or 180 degrees. So then you get sine of those two are 0. But when I get something like this, what I like to do is draw the vectors in the same direction as the field that make up my vector that's at an angle. So here my vectors that make up this diagonal go down and over. So if I just use my right hand rule, right, then I can point in this direction here with my index finger, and then I can take my middle finger and make it point up in the direction of B, and that tells me that the B field, or the force is going to be on this wire is going to be out of the page. So I've got a dot here for out of the page. And let's try it on this one. Okay, so I've got this vector, and to make this vector, I go this way and up. So this is the part of this vector that is perpendicular to B. So again, I point my finger this way, and my B field is up the page here, and so again, my force is out of the page. So out of the page is what I'm looking for. So that tells me I either have B or D. And then how do I figure this out? Well, I can use the math now. So I'm going to get a force from each of these wires out. So I know I'm going to have the force on both is going to be 2 times something. So my I is going to be 2 amps. My L is going to be, let's see, where is it? 1 meter. B is going to be 2 times 10 to the minus 3 Tesla. And then I have sine. So in this case, I just have sine of 30. So sine of 30 and sine of 150 are going to be the same. So I'm just going to use the sine of 30. So here I've got F is equal to 2 times 1. So that's just going to give me 4 times 2 to the negative 3. So that's just going to be, let me erase that. Maybe. Doesn't want me to erase now. Okay, so let's just cross it out. So 4 times 0.002, and then I've got sine of 30 is a half, times a half. So that means my force is going to be equal to 4, right? So this 2 and this 2 cancel, but I still have the 0.001 here. So 4 newtons. And we know it's out of the page, so it's going to be B is the answer.